you know. Now, this one here, what I told you guys was, I'm going to rearrange it so it looks like this. No reason, I just like doing that. Okay, I like to have the square root second and the number. Of course, it's the way I've always done things. Multiply top and bottom by what's called as the conjugates. Is that right? So we got 1 minus root 5, and then 1 minus root 5 top and bottom. Does everybody know how to get the conjugate? You just look at the original, and in front of the square root sign, you put if it's a plus, you turn it into a minus, and if it's a minus, you turn it into a plus, and leave the regular part alone. The effect this has is you're basically multiplying the denominator by its difference of two squares, so to speak. Does that make sense? And every single time you do that, the denominator should have no surds left. That's what should happen. So we get 4 minus 4 root 5, and then what happens down here? 1 times 1, 1 minus root 5 plus root 5. Root 5 times root 5, Charlie?
Minus 5.
Minus 5, yeah, fair enough. The root 5's cancel, and what's left? 4 minus 4 root 5 all over. Minus 4. Don't like having a minus 4 on the bottom either. Multiply top and bottom by minus 1. And what would you get? Multiply top and bottom by minus 1. You get that. Then divide top and bottom by. Divide by 4. What's minus 4 divided by 4? Minus 1. 4 root 5 divided by 4? Root 5. Ben's going to do the next one. Actually, the next one's too easy. Ben's going to do a more difficult one. Ben, you're doing part 4. Awesome.
One here looks like top and bottom 8 plus
So you got root 8 minus root 2. And what did you do?
top one root 8 plus root 2.
Yeah, you could do that. I'd be pretty happy with that way of doing it. Could anybody suggest an alternate? Somebody might try it this way instead. And we're going to compare both methods to each other. That's our root 8. What would be the other one you went for? What did you say? No. I've just changed. Just change the root 8 into minus root 8. So imagine I changed it around like this for no reason. Imagine I just redistribute it like this. That it's minus root 2 minus root 8. Yeah? Where the root 8 is the second part, not the first part. Yeah? I'll say plus root 8. By false. Plus root 8. What would be the conjugate of the top and bottom then? Minus root 2 minus root 8, top and bottom, yeah? We're going to try out both ways, because not everybody thinks alike. Let's see what happens. They're definitely the conjugate of each other though, aren't they? There's definitely the difference of two squares. That's the main thing. So what happens now? Let's find out. 1 times root 8 by root 2. Root 8 plus root 2. Alright, let's do the next one. Ben, you're up. Root 8 by root 8. Yeah. Then root 8 by root 2. Which is root 6. Root 16. And what's root 16? Yeah. I think they cancelled anyway, so you didn't really need to do that, did you? And what's root 2 by root 8? Yeah, minus 4 as well. You didn't really need to do it because they're going to cancel anyway, weren't they? So there's no real need. And what's minus root 2 by root 2? Okay, and then what you get on the bottom? Yeah, so root 8 plus root 2 all over 6. I guarantee you that's not the answer in the back of the book. Guarantee you. Why not? Yeah, there's a much easier way of doing this question at the very beginning. None of us spotted it. What can you break root 8 into? Root 4, root 2, which is? What's 2 root 2 plus root 2? 3 root 2 over 6, which is? Root 2 over 2. Alright. Would the red way work the same way? If we did it the red way, would it work the same way? Daily. Multiply 1 by minus 2 minus root 8. What do you get? Minus root? Yeah. Root 2 by minus root 2? Oh, sorry. Minus root 2 by minus root 2. Plus 2. Root 2, minus root 2 by minus root 8. So minus root 2 by minus root 8. Multiplication. Yeah, which is technically root 16, which is technically 4. But look, we'll do it this way this time. And the other one's going to be the opposite, isn't it? Like that. Root 8 by root 2. Yeah. And then root 8 by root 8. Yeah. And what's the difference this time? You get this answer here, which is divided by minus 6. What happens if I multiply top and bottom by minus 1? What does it convert into? Anybody? Turns into? Over here. Turns into the same thing, doesn't it? Multiply top and bottom by minus 1. Turns into the same thing. You get the same answer. Now, is there any really smart people? Alright, I'll move on. No. What could you turn root 8 into at the very beginning? Huh? You could have turned it into 2 root 2. And that's minus root 2 all over 1. And what do we get there? 1 over root 2. Huh. Why didn't we get that? So multiply top and bottom by root 2. Ah, there you go. And you get root 2 over 2. Which way was the easiest? The third way, yeah. Did anybody do it that way? Oh, legends. Anybody go for red? You get out? Yeah. Well done. Anybody go for blue? Yeah, that was a lot of hard work, wasn't it? Alright, let's move on. Okie dokie. Lads, I want you to do 7 part 2 now. I want you to get a common denominator and figure it out. For those of you that are struggling with the start off, you basically you have one denominator here, you have the other one over here. Oh, 3's actually works. Sweet. Missed the freeze button. When I get to look at other stuff and I don't have to pretend I'm working. Now, alright lads, here's what you do. 2 plus root 5 on the bottom and 2 plus root 5 on the top. And on the other side, 2 minus root 5 on the bottom and 2 minus root 5 on top. Now they both have a common denominator of 2 minus root 5 and 2 plus root 5. Alright, finish it off and I'll follow you into 9 then, okay? Should have got 8 plus 4 root 5 plus 4 minus 2 root 5. You then should have got 12 plus 2 root 5 on top. But the bottom is the difference of 2 squares, so you should have got on the bottom you should have got 4 plus 2 root 5 minus 2 root 5 minus 5. You should have got a denominator of minus 1. There we got minus 12 minus 2 root 5. Yeah? I'll leave it there. When you have a minus on the denominator.
I don't have a minus in the denominator.
Alright, do you have 2 minus root 5 and 2 plus root 5?
Yeah, I have that.
You should end up with 4, take away 5 then. You should end up with 4 take away 5. Yeah. Alright. Question 9 is one of the handier ones. 2 by 2 is 4. 4 by 5 is 20. 2 root 5 by 3 root 2 is 6 root 10. 3 root 2 by 2 root 5 is minus 6 root 10. 2 root 5, sorry, 3 root 2 by 3 root 2 is 9 root 4, which is 18. They cancel. 20 minus 18 is 2. 2 equals 2. Question 11. You have 3 parts on top. Just take it 2 at a time, okay? 2 at a time. 6. 2 root 5. 3 root 2. Ouch, that's nasty. Then 3 root 2, then root 2 by root 5 is root 10. Alright. Okay. Key thing when you're working on the numerator, okay? Put the guns away daily. Now, alright guys, there's 4 in the first bracket, there's 2 in the second bracket, so how many parts am I going to have on my numerator when I'm done? I'm going to have 8 different parts to deal with here. This is going to be great. It's going to be fantastic. 6 times root 5 is 6 root 5. 6 times 2 is minus 12. 2 root 5 times root 5 is 10. 2 root 5 times minus 2 is minus 4 root 5. Then 3 root 2 times root 5 is 3 root 10. 3 root 2 times 2 is, times minus 2, minus 6 root 2. And then finally 10 times root 5 is root 50. And the last one is minus 2 root 10. There's all 8 of them. I'm not even going to touch the denominator yet. Don't even want to go near it yet. So, let's look at what items look alike. 6 root 5s, 4 root 5s. What's the root 50 going to turn into? Root 50 is root 25 roots 2, which is 5 roots 2. So root 50 is 5 root 2. Happy with that. Okay. How many root 5s do I have? I have 2 root 5s, okay? That's great. How many root 10s do I have? 3 root 10 and 2 root 10. What does that leave me? Just root 10 there. Okay, and what about the root 2s? Oh, that's a terrible colour, but we'll go with it. Anybody see the root 2s? Minus 6 plus 5. Anybody? Minus root 2. Delighted at this question. Now, what's minus 12 plus 10? 2. Hooray!
Second part.
And we're only half done.
Okay, black one.
Here? Root 10. Alright. Now we're going to have a look at the bottom. See what happens. Okey-dokey. Root 5 times 1. Root 5. Okay. Root 5 times root 2 is root 10. Plus root 10. And minus 1 times 1 is minus 1. And minus 1 times root 2 is minus root 2. I have a feeling we're missing a trick. We are, I don't see it. What's the answer in the back? Really? Now, do you know what's a good way of checking? I know you don't get this luxury in the exam, but to see if we actually made a mathematical mistake at this point in the question, what you could do is you lob it all into the calculator and where you currently are. And if it doesn't come out as root 2, you've known that you already made a mistake. So this can be very helpful when you're doing a question for homework. Because you won't know what the answer is. The lads told me the answer is root 2, didn't you? So you can either do this for homework and you just put it all in. If it doesn't come out as root 2, it means that we've gone wrong somewhere. And oddly enough, the answer that came out was root 2. So we somehow had to figure out a way to turn. We haven't made a mistake. That is root 2. You put root 2 in your calculator, it's 1.414. Go off you go. Alright? So we somehow had to figure out a way to turn this into root 2. Ain't gonna be fun. Okay. It should be root 2 on top, isn't it? The bottom is root 2 smaller than the top. If I multiply the bottom by root 2, it should turn into the top. Yes. The two of them? Absolutely not, and I'll tell you why. Imagine 9 over 7. Yeah? I changed 9 into 5 over 4, and I changed 7 into 5 plus 2. What happens if I cancel the 5s? Is it still 9 over 7? No, so that math is flawed. It has to be multiplied, okay? So that can't be done. So there's something we're not seeing here, right? So what I'm looking at is here. I'm looking at this. I never was spotting this either. So I'm looking at that one and this one. I'm looking at the blue one and the other blue one. Ah, there it is. Ah, there it is. Found it. Never would have got it in the exam though. What I would have done in the exam, oddly enough, is I would have threw it all into the calculator. And when I threw it all into the calculator, I would have got 1.414. And I would have said, oh look, you never told me what to write it as. But then I would have recognized 1.414 as root 2 and I would have wrote it down. But here's actually what happens. If I divide, first of all, I'm going to rearrange them. So I'm going to change, is it okay if I change the green and the yellow on top for a second? So I'm going to put the root 10 first and the 2 root 5 seconds. By the way, nothing like this is ever going to happen in the exam. So just don't worry about it. Okay? Everybody cool with that? So that's my green and that's my yellow. Right? Now get this. I'm going to factorize out root 2. So I'm going to divide root 2 out. Once I'm going to divide root 2 out, what goes on here? Once you take root 2 out of root 10, what's left over? Root 5. What happens when you take root 2 out of 2? Is root 2 root 5? Think about it. What happens when we multiply the root 2 by the root 2? It becomes 2. Does it match the yellow part? It does. Right, keep going. Once again, this would have been a stretch in the exam. That becomes a minus 1, and the 2 becomes a root 2. What you know is about the numerator and the denominator now? What can I change root 10 into? There you go. And long behold, nobody would have ever got this. Answer's root 2. Alright, so quite simply, just give them the same denominator using the usual trick. You good? Move this root 3 denominator, put that on top and on bottom. And then put the 1 minus root 3 top and bottom here. And long behold, you should get root 3 by root 3, which is 3. Minus 1, that's a minus 1. The minus is up there, so you get minus 1 plus root 3 all over as a single fraction and simplify by rationalizing the denominator. Alright, we're not quite done yet. Root 3, yeah? And then what's root 3 by root 3? 3. Did anybody get 2 plus root 3 over root 3 minus 3? But I guess whatever, 15 or whatever. I never write square roots like that. I always write it like this. The way my brain works. And I find that comes in handy when I'm doing the conjugate. So the conjugate top and bottom will be minus 3 minus root 3, and then the other one will be minus 3 minus root 3. Multiply this out, and the denominator should be free of surds in a second. Did anybody get this far? Alright.
Can't you just leave those cheap right?
Here. Read the question. What? Rationalizing the denominator means that the denominator cannot be irrational. Irrational will be any surds like root 3 or anything like that. So 2 times minus 3 is minus 6. Minus 2 root 3. Minus 3 root 3. And then root 3 by root 3 is minus 3. All divided by, yeah, I have to multiply this out. It's going to be 9 plus 3 root 3 minus 3 root 3. And then root 3 by minus root 3 is minus 3. And 6 minus 9 minus. Yeah, is that the answer? Okay. David present.